Last time we started section 2.3, we had taken a look at four other set operations. Intersection, union, relative difference. Those were the three main ones. And then the last thing we ended on was called the Cartesian product. You guys remember those? And the Cartesian product created ordered pairs. All right, I want us to take a look at those three main ones that I just referenced. And we're going to take a look at how we solve intersections and unions and so forth with Venn diagrams. Now, I will say right now that when you get to your test on Monday, if you have something that says to find this intersection and so forth, I'm going to expect to see it done like I'm doing it in class, okay? So pay particular attention, note exactly how we're doing it, write it on your note card, whatever it takes. There are some problems, and this is a very good example, this one, where I could probably logically just sort of reason it out, okay? But once I get three sets involved, that becomes exceedingly more difficult. So I'm going to show you on a simple case how to make sure that you're getting them sort of organized in your mind correctly. And then we'll do more complicated cases very soon. All right, so to create a Venn diagram, we've got two sets on this one. That's what it says. We have sets A complement and B complement. So we need two circles for sets, and they'll be sets A and B. Okay, so we're going to label them. This is A, and this one's B. And we label the universal set U out here. And what we're going to do to organize our thoughts, this is the part that people, I don't know if they don't like it or if they forget it or what exactly it is, but when we fail to do this part is when things usually go awry. We're going to put numbers in the different regions, okay? I typically start with the number 1 in the far left circle, 2 in the middle between them, 3 in the far B circle, and then 4 in the outside rectangle. These aren't really representing anything except for the region that they're in. So I could use letters just as well, A, B, C, D. That'll be fine. I just choose to use numbers. Okay? Everybody good so far? All right. This is how you'll always start the problem, with numbered regions of circles overlapping inside of a rectangle. And then you're going to go to the information that they're asking you to find. And you're going to do it piece by piece. If there's parentheses, you'll do the inside of the parentheses and work your way out. No parentheses on this one. And what we're going to do is we're going to label the pieces that it asks us to find information about. So the first one is A complement. Now A complement means everything that is not in A. So what numbers do you see that are not in A? 3 and 4. And then the next one you see is B complement. What are the numbers you see that are not in B? 1 and 4. Okay? And then kind of like when we're doing arithmetic or whatever, we kind of draw this line that says, and then the result of something is, right? We like to do that in math when we're writing things from, in a vertical sense. Well, what we're trying to do on this one is we're trying to find A complement, union, B complement. And if you remember from last time, union means I get everything. Everything in either A or B or both. So what numbers are in A or B or both? 1, I didn't mean A or B or both, A complement or B complement or both, the ones that I'm referencing. 1, 3, and 4, right? Okay, and I'm using this piece right here to make that determination. I just look up there and I say, oh, I'm going to include everything because it's a union. Everything is A, B, complement, each of the individuals, which is 1 and 3 and 1 and 3 and 4. Everything I listed. Now, everything that I've done so far is the work that supports my answer, but it's not my answer. My answer is to do what I've been asked to do, which is to use a Venn diagram to shade. I need to shade the answer in the Venn diagram. So in particular, I need to shade region 1, region 3, and region 4. Everything gets shaded except for the overlapping piece in the middle, region 2. Okay. Any questions about this one? Because they will get more difficult once we have 3.
So it is okay
circles.
that when we shade it, it's all the same color?
Yeah, absolutely.
So why isn't 2 involved at all?
Because 2 is not in A complement and 2 is not in B complement. So it's not in the union of the complements. Okay, let's try one that's a little bit more difficult because it's got 3 sets. Got 3 sets, which means I need 3 overlapping circles. So it looks something like this. It looks like an abbreviated Olympics rings or something like that. Again, there's nothing special about my labeling. I tend to label top left, kind of like you're reading from left to right, A, B, and C at the bottom. And the universal set U is on the outside. And just like with the 2 circles, we're going to number our regions. We just have more regions to number. And again, I start with the bottom or the top left, where A is, and I go across the top. So 1, 2, 3. I go through the middle, 4, 5, 6. The bottom by circle C, and then the 8 on the outside. If you number yours differently, that's totally fine, okay? I mean, I'm going to be a little bit grumpy because it's going to be harder for me to grade. But it's okay in the sense that it's not wrong, okay? The ordering of where you put the numbers is not a big deal, all right? It's that the work you go to do next supports the numbers or uses the numbers that you've already written down. Okay, everybody clear on that? Okay. So I mentioned this on the last problem, that when there are parentheses, we're going to work from the parentheses from the inside out. So I'm going to start inside my parentheses, and the inside my parentheses are A and B. So this isn't a complement, this is A. So what numbers do you see located inside any portion of circle A? 1, 2, 4, 5. Same thing for B. What numbers are inside circle B?
2, 2, 3, 6.
Excellent. And then we're going to do whatever it said to do with those 2 sets. In this particular problem, it says to do the intersection. What does intersection mean? Where they overlap, what they have in common. And in this one, it's 2 and 5, right? And if you go back to your picture, you should be able to look at that and go, well, of course it is 2 and 5. 2 and 5 is what A and B circles have in common. Now I'm supposed to take the result of this, and I'm supposed to do this with the circle C. So what in the world, what grouping of numbers are inside circle C?
4, 5, 6, and 7.
4, 5, 6, and 7. And then I'm supposed to use those 2 sets, that is the result of A intersect B and C, and I'm supposed to find their union. What does union mean? All the numbers that are included. So this includes what? 2, 4, 5, 6, and 7. With union, I get everything. So over my picture, I shade in 2, 4, 5, 6, and 7. Any questions on that one? All right, we have one more of this variety. A little bit more complicated because we've got the 3 sets like the last problem, but we've got some of the complements in it like the first problem. Okay, we've got circles A, B, and C in the universal set U. And our numbers across the top, 1, 2, 3, across the middle, 4, 5, 6, 7's in the bottom, and 8 on the outer edge. And looking inside my circle, inside my parentheses, it says I need to do A and B complement. So, what numbers are inside circle A? 1, 2, 4, and 5. And then what does B complement mean? Okay, what are all the numbers that are not in B?
1, 7, and 4.
Okay, 1 I got. What's next?
4.
Okay, 2 is inside circle B. At least it is in my picture. 4 I agree with the numbers I've written down. 1 and 4. What else?
7.
Yeah, don't forget 8. Don't forget the number that's on the outside of the circles but still inside the rectangle. What am I supposed to join these together with?
Intersection.
The intersection. What does intersection mean?
Where they overlap.
The things they have in common, where they overlap. That looks like 1 and 4, right? right, so now I've done everything inside the parentheses. Working my way outside, I've got C complement. So what numbers go with C complement? 1, 2, 3, and 8. So everything outside of circle C. And how am I supposed to combine these? Ooh, intersection again. Okay, so this is the intersection. What is the intersection of these? 1. Just plain old lonely 1. So in my diagram, I shade 1. Okay? I want to believe that when I get to the test, everybody's going to put numbers in circles, and they're going to all show you are going to all show your work. That's what I want to believe. So, huh?
I know.
This is the easiest way. There are a lot of people when we give a 2-diagram one who can reason it out. They can think about it in terms of what is and isn't included without any shading. There is one other way too. Ariel mentioned, are you okay with me shading in one color? The first way that I learned how to do this did not include numbers. It included shading with cross-hatching things. So like you shaded all of circle A where your slants were going diagonal like this, and then you shaded all of circle B complement where your slants were going like this, and then you looked at the shading and you looked at where things were double shaded and where they were single shaded, and it's a lot harder. And I actually had a student show me, hey, this is how I've seen this done before, what do you think? And I thought, oh, I like that a lot. So this is how I've taught it ever since. Yeah. Okay. The next thing we're going to do with Venn diagrams is we're going to actually use the information where the numbers that I write inside of the circles actually have a meaning, not just indicating the location, okay? So the numbers I've done inside my circles so far just sort of indicate like, this is the part of the circle I'm in, okay? They're just a label. The numbers I'm about to put inside the circle are not labels, they're cardinalities. That is how many items are inside a portion of a circle. Now this diagram that I'm about to show you right here is not altogether helpful because there's no context, but I just want to show you how to do it, and then I'll show you how to do the context part of things, okay? So we're going to take a look. What I want you to recognize so far with the information you're given on this problem is that there are 3 circles, right? Do you see A, B, and C listed? So my diagram will start out like the last 2 problems I've done with 3 circles labeled A, B, C inside of the universe U. Now here's the problem, it's not a problem, but here's the catch on this. If you start at the very first place in this information, it says n of A equals 24. What that means is that the entire circle A, these 4 regions that are in circle A have to total up to 24. And aside from guess and check, that's not especially helpful information, right? I mean, how do I decide what number goes where? Do I put a 10 somewhere? Do I put zeros anywhere? What if it's all 24 in one little piece of it? I have a lot of options here. So those 3 first pieces of information are highly unhelpful. Does everybody see that? All right, so let's look at the second line of information on my screen, the intersections. A intersect B. Well, A intersect B is right here. Now, that's not as bad. It's not 4 regions, but it's still 2, right? And again, it may not be infinitely many options, but I still have a lot of options of the way I could break the number 10 into 2 different regions. Is it 5 and 5? Is it 1 and 9? Is it 0 and 10? I don't know. Lots of choices. Okay, so that second line of information, also not a great place to start. Let's take a look at this one though. Last line of information talks about A intersect B intersect C. Where is that? It's the very middle one, right? And how many regions are there in the very middle?
3.
1. Yeah, the very, very middle. There's 3 overlapping circles, right, and 1 region. So that's where we're going to start. We're going to start with the one that gives us the most information, so it identifies the smallest location where we can put things. And there's always something in the diagram that's going to be like that, where there's no guessing and checking. You should be able to simply put the number in and then can work your way out from there. So that's where we're going to start. We have the number 6, and the number 6 is supposed to go in the very middle. Okay? As we find the pieces of information, I'm sort of going to mark them off. Maybe you'd like to as well. Now that I have that piece of information, also, let me make one more mention. I haven't talked about n of u equals 50. N of u equals 50 means that everything inside the whole rectangle has to add up to 50. So again, that's really unhelpful information at the beginning, right? I don't have anything labeled. I don't want to start with that. Now that I have this 6 labeled right here, though, if I go back to the line before where it says N of A intersect B, the intersection is just this sort of a, I don't know, fish shape right here in the middle. It includes the 6, and it also includes this piece, but I should be able to tell me now, you should be able to tell me what this little piece up here above it is. It's 4, because these 2 pieces have to add up to 10. So this one is 4, and I'm done with this piece of information. Now on that second line as well, it says B intersect C. Well, B intersect C is right over here. Again, I've got a 6 and I've got a blank spot, and it's supposed to add up to 8. There are 2. And that piece of information is finished. Last piece on the middle row says A intersect C. That's this one over here. I've already got a 6, and it's supposed to be a total of 15.
9.
I need 9. Oops. Okay, working our way outward. I can actually go back to the first line now. It said N of A is 24. We talked about the fact that this circle A had 4 regions, but we now have 3 of them filled in. So I've got a 4, a 6, and a 9. How many is that? 19. How many more do I need to hit 24? 5. So there will be 5 on the outer edge of circle A. And I've used N of A equals 24. Now I have N of B equals 24. Everything in circle B equals 24. Right now there is a 4, a 6, and a 2. That's 12. So how much is left? 12 in circle B. So that one's done. The last one on the top line is N of C equals 26. My bottom circle C, I've got a 9, a 6, and a 2 in it. How much is that total already? 17. And I'm supposed to hit 26, so how many am I short? 9. So there's a 9 down here. Okay, where have I not put a number? On the outside. Does the number 50 go on the outside? It doesn't directly go on the outside. Right, I need to count what I've already put in, and then I need to take it away from the 50 total. So everything inside the whole rectangle is supposed to add up to 50. Okay, so I've got 5, 4, 12, 9, 6, 2, and 9.
Couldn't you just add A, B, and C?
No, because what happens if you add 24, 24, and 26 together? It's already more than 50, right? Yeah, because you'd be adding some of these overlapping places twice. That's why. Okay, what happens if you do add all these together, all the numbers that are present on your diagram? 47? 47 is what I have written down as well. So how many more do I need? 3. So there are 3 out here. And I'm done with that piece. Okay. So this is the how-to example. It's not really like, well, why would I, right? What would I use this for? So I'm going to get to the what would I use this for next, but this is the how we use it, okay, how we do it. All right, so we've got a couple of examples for how we use this. We've got Joe Long. Joe Long works on albums for musicians. Last year, he worked on 12 projects. He wrote and produced 2. He wrote a total of 5, and he produced a total of 7. We've got some questions that we're going to answer, but those questions will be much easier to answer if we create a diagram to try and organize the information. So we are going to create a Venn diagram. I totally don't have very much space, but we'll try and see if I can squeeze it in right there. How many circles does our Venn diagram need on this problem? 2. What are the 2 circles representing? Yeah, the ones he wrote, I'll call that W, and the ones he produced, and I'll call that P. It's the only things that we're given information about, 2 different categories of options here. Now, it says he worked on 12, he wrote and produced 2, he wrote a total of 5, produced a total of 7. I don't know why the 7's not in 7 as the number and 5 is, I don't know, evidently did not write this very well in terms of English, but nonetheless. Which number is going to be the most helpful to start with? The 2. Where's the 2 going to go, Abby? In the middle, it says he wrote and produced 2. That's the overlap. Okay? Start with the piece of information that gives you the most explicit location on your diagram. And I'll highlight them as we've done them. So wrote and produced 2. We're done with that. Okay, what do you want to do next? Wrote, how many did he write? 5, a total of 5. So do I put a 5 in the outside region? No, I put a 3 because right now that whole circle is the total 5, right? We wrote 5. What's next? Produced a total of 7. So what number do I write and where? 5 and where the P region is right now. Okay, so 5 and the 2 in the middle make the total of 7. What else? I need to do the outside, so I haven't labeled it yet. I'll label it U. Right, I need to add them together and subtract from 12. Added together, it is now 10, and subtracted from 12, it is the 2. You're right, so there's a 2. All the work is in the creating of the diagram. Okay, after that, it's very easy to answer the questions based on the diagram. Question A, how many projects did he write and not produce? 3. It's the outside of the W region. Write and not produce. Yes, Abby?
What about like the 2 on the outside?
He didn't write or produce those.
He just worked on it.
Maybe he worked on them, maybe he sang in them, we don't really know, but he didn't write them and he didn't produce them. He just worked on them somehow.
Would we shade it in on our diagram?
We're not shading on this one because we're going to answer several questions about it, but if you were asked to shade, that is the region you'd shade, is that where the 3 is located right now.
So we can actually use this diagram for...
Yes.
Okay.
We need one diagram for this whole problem. Exactly. How many projects did he produce but not write? 5. It's the outer P region. And how many projects did he neither write nor produce? 2. See how easy the questions are after you get the diagram. And I will grade your diagram, I grade your answers based on your diagram. So if you make an error in your diagram, then just make sure your diagram is what you're using to support your answer choices. All right, last example. This one's fun. A youth group was asked questions regarding the songs they had learned as children. After surveying the 34 youth, the following were obtained. 15 had learned Jesus Loves Me, 19 had learned the B-I-B-L-E, 28 had learned This Little Light of Mine, 13 had learned Jesus Loves Me and This Little Light of Mine, 15 had learned Jesus Loves Me and the B-I-B-L-E, 14 had learned both the B-I-B-L-E, this, I don't know why it says both, had learned all, it should say all, had learned all of the B-I-B-L-E and This Little Light of Mine. Oh no, it is both. Why I put both on that one and not both on the previous 2, though, I don't know. 13 had learned all 3. I need to go back in this lesson, I think, and get some grammar straightened out. My goodness. Okay. At any rate, the information is here, and we're going to answer some questions, but the answers to the questions will come from a diagram that we create. So the Venn diagram is where we're going to start. As we do this Venn diagram, what piece of information is going to be the most helpful to start with? Of the, I don't know, 7 or 8 sheets of pieces of information we're given.
The intersection of all 3 songs.
Right. And we do, in fact, have 3 songs. So I drew through 3 circles. I'm just going to go in order of the way they're first listed. So the outer circle on my left is going to be my Jesus Loves Me circle. The outer circle on the right is going to be the B-I-B-L-E. And my bottom circle is going to be This Little Light of Mine. So if you choose to write things out as A, B, and C, you need to tell me what is circle A. It's Jesus Loves Me. What is circle B? It's This Little Light of Mine, or whatever you choose to do, okay? So I just usually write an abbreviated version of what the category is inside the circle. It makes it easier. All right, so Amy mentioned that she wanted to start with the very center of the circle. So what number is going to go in the very center of all my circles? 13 had learned all 3. So in the middle of this circles, I'm going to put a 13. What piece of information would be second most helpful?
15 and 9. I mean, you could do either 15 and 13.
15 or 14.
The 15 or the 14 or
13.
the 13. Any of the 3 above there. So how about we just go from the bottom up? Are you guys okay with that? Okay, so I'm going to go with the 14 next. Right here, didn't mean to do that. Right here I had 14 had learned the BIBLE and this little light of mine. Okay, so this is the right-hand side of my diagram, BIBLE, this little light of mine. It's supposed to be 14.
So what?
I need one more. Okay, there's 14 now represented that intersect those two circles. The next one, 15 for Jesus loves me in the BIBLE.
2.
So I need 2 on the top, right? That's the BIBLE and Jesus loves me. The next one is 13 is Jesus loves me and this little light of mine. Right. And I did that on purpose because I want you to understand it's okay to have a 0 in your diagram. There's nothing wrong with that. Okay? Alrighty then. Now what?
The 28.
Sure, we can keep going up, right? 28 had learned this little light of mine. All right, so this little light of mine is my bottom circle. I've got how many in there so far? 14. So how many more do I need? 14. I have 19 had learned the BIBLE. There's 16 there now, so I need 3 more. Nice. We're getting close. 15 had learned Jesus loves me. So there's a 0 out here again. Okay, are you guys good?
Yep.
Are we done?
No, we have the outside.
We still need the outside. How are we going to figure out the outside, Amy?
We're gonna add all the numbers we have in the circle together into the number of youth, which is 34 minus everything we already have.
You got it. So we're going to add 2, 13, 3, 1, 14. We're going to add all those together. That's 33. So how many does that leave? 1 to go on the outside. There's my universal set.
So one kid didn't learn any songs, right?
That's what this is saying. Didn't learn any of these 3 songs.
Okay.
I think they might all be in my youth group at my church, just so you know. We have a lot of really rough kids in our youth group at church, so I'm sure they didn't know probably any of these songs. All right, now it says how many know or how many learned exactly one of these songs.
17,
Okay, so tell me what numbers you added together.
0, 3, and 14.
Okay, so Ariel, you had asked a question earlier about your homework, which we'll address later, but this is the work I would want to see on this, and the reason why is because then I'll know what numbers you added together. So if you inadvertently put a 1 where you should have put a 0, I might be able to figure out what part of your diagram you were looking at.
Okay.
Okay, so we get 17 from this result. How about at least 2? What is the phrase at least 2 going to mean?
There's 1, 2, or more.
2 or more. So it means either 2 or all 3, right? So what are the numbers in the categories that are 2 or all 3?
0 plus 2 plus 1 plus 13.
0 plus 2 plus 1 plus 13 for a total of what? 16. None of these. That's the one that's on the outside, right? And how about this little light of mine only? 14. All right, any questions on the processing of that? Okay, last question for this day. Is the Cartesian product, we did the Cartesian product last time, remember it was the ordered pair thing? Is the Cartesian product commutative? So commutative means you can change the order of things and it works. So for example, 5 times 3 is 3 times 5. So multiplication is commutative, okay? Is the Cartesian product commutative? So in other words, if you take the set A and you find A cross B, does this equal the set B cross with A?
Yeah. And doesn't it kind of matter, like, the order that you figure it out? Like, because if you just put, I don't know, 28 in this little line of mine.
This isn't about the circles we were doing. This is a Cartesian product. This is a different, yeah, take a step back from last time. Yeah.
It changes the order pair.
Yes. So this particular diagram up here is A cross B, right?
Yeah.
A had letters, B had numbers, and when I wrote them out, I get the ordered pairs x1, y1, z1, x2, y2, z2. Would those ordered pairs be different if I had done B cross x? Yes, they would. I'd get 1x, 1y, 1z, 2x, 2y, 2z. And in general, 1x is not the same as x1, right? I mean, just think about your ordered pairs on a number line, right? Is the point 1, 2 the same as the point 2, 1? No, it's not. So this one is not commutative. So the answer is no, because in general, and I'll give you an example, like the ordered pair 1, 3 does not equal the ordered pair 3, 1, right? It just doesn't work. This would be a Cartesian plane example of one that you kind of know and love.